interesting. Trust him. Yeah. So somebody block the doors. Quick. Somebody block the doors. Okay. Q-Jacks will take you out if you leave. Stand fast. Okay. I'm going to, and since he was so gracious to jump in so quickly, I don't think we have his introduction. So I'm going to let him introduce himself, but he needs no introduction, I'm sure. But here you go. I'm going to go ahead and turn it over to Mr. Damon.
Thank you. That's okay.
Go ahead and get his to him so we don't forget.
Check. Hey, wait a minute. You're plugging an unknown device into my computer, and I'm letting you do this. And now you're walking away with my hardware. What? Yeah, that's mine.
Wait, I thought he said it was yours. Who's this, George?
This is mine, yeah.
Oh, you.
All right. This makes me feel better. It's only going to get better from here, right? Thank you for coming. I am not Keith, as the program said. My name is Damon Small, and I'm not here to talk about the CTF. If you're here expecting that, thank you for staying, or if you'd rather go see Haddix, that he's speaking right now too. Again, Damon Small is my name, and I'm talking about, it's a bit of a history lesson, and I'm trying to answer the question, why do we have the security problems that we have today? And I'm going to be comparing one huge infrastructure that was built by the government to another huge infrastructure that was built by the government. And trust me, this will get interesting. I know it sounds like a weird topic, but bear with me. And it's a new slide. I just wrote this presentation, so I'll keep it on the short side as well, as thanks for y'all coming to this. So this is me. I'm the technical project manager at the NCC group. I actually just started very recently. I'm a Louisiana native, and as we say here, I'm not from Texas, but I got here as fast as I could. I've been in IT since 1995 and an InfoSec geek since 2001. And I actually studied music in undergrad. So, I was supposed to be a famous rock and roll drummer by now. Doing the computer geek thing instead, it pays a lot better. But I went to grad school in 2005 to try and become legit. I love participating in our industry. I love being a part of InfoSec. So please stay in touch. If you have comments or criticisms for me, I'd love to hear them. There's some email addresses, and you can see my ramblings on my blog if you'd like to as well. As I said, I work for the NCC group. Obligatory quick about us. We're based in the United Kingdom. We've got offices in North America and Australia. And we're, rapidly growing in this space, and hope we can do business with you later. So, like I mentioned, as a security guy, I get this question. I'm sure all of you get this question a lot as well. Why didn't they think of that? We've got plain text protocols. We've got weak authentication. We've got web applications that don't work right. Why didn't they think of that? When you hear that question, at first it sounds like, well, I don't know, how do you even answer a question like that? But I think it's a fair question, and I think if you look at how the internet came to be as it is now, it'll help us understand why we have some of these problems, and then moving forward into the future, what we should do to prepare for the problems that we'll see down the road. So again, it's a big analogy. Excuse me. We've all heard the information superhighway, right? So I think it makes sense that we start by talking about that. So our story goes all the way back to 1919. The United States military decided they wanted to move 80 vehicles from Washington, D.C. to San Francisco. Then Lieutenant Colonel Eisenhower was involved in that project, and it was 3,000 miles, and it took them 2 months to do it. And Eisenhower realized, look, if we're going to defend this huge country of ours, it can't take us this long to move from one border to the other. We need a better way to efficiently move from one place to the next. So later on in the 1930s, Eisenhower found himself in Germany. Those of you that study history might remember there was something going on in Germany at that time. Well, the Germans had already started working on their Autobahn, which is their national interstate system, and you can see it's quite comprehensive today. And Eisenhower saw the efficiency with which they could move around their entire big country, and he thought that's a really good idea. we should have some of that. And so once he became president, although there were national highways in place in the United States, there wasn't a single cohesive interstate system as we have today. So as president, he funded the national interstate system. And the initial requirement, as he remembered from 1919, was just to be able to move military vehicles from one place to another efficiently. So it was a very specific use case, a very specific goal that he had in mind. But once the thing was built, normal citizens could use it. And so once he worked hard to get the money to fund, and in 1956, the Federal Aid Highway Act was passed. And so he's kind of known as the father of the interstate system. And in fact, in 1990, the name was formally changed to the Eisenhower Interstate System, so that's what it's called. And you can see there's roads all over it, and if you live in Houston, you get to drive on some of them every day. And it's a wonderful thing. So it started off as a DoD project, but private citizens could use this interstate system, and it became very much a part of our culture in this country. Even well before then, in other cultures in the 1900s, the Michelin company that makes tires put out the Michelin Guide to restaurants. And the reason they did that is so people that were driving around France could find good restaurants to go to. So there's been a long idea of car culture, particularly in this country. If you think about historic Route 66 and how much of a big impact that had on societies, and entire towns would spring up around where the road was. So you put an infrastructure in place, and all these amazing sociological and economic things start to happen. Of course, if you've seen the movie Cars, you know what I'm talking about. And again, entire cities lived and died based on the traffic that they would see on roads. And by the way, does anyone know where the middle of Route 66 is? Has anyone ever driven it? It's in Texas. So, midpoint. I've never been there. I should go there at some point. So, what's my point in these introductory comments here? Again, the interstate system was a very specific infrastructure that was built for a very specific use case, and it ended up having this profound economic and sociological effect once the private sector got involved and once regular citizens started using it for travel and recreation. So, the initial requirement, move military vehicles. What ended up happening is now the interstate system is a very key infrastructure that the DoD started building, and now it's just something that's very much a part of our culture. So you see where this is going, right? So if we bring this back to what we're here for, which is talk about InfoSec and Internet things, the Internet was also a DoD project. Now, there's a lot of people from other countries that were working on packet switching technologies as early as the 1950s. We like to say that the Internet is completely an American invention that was invented in the 1960s, but there were a lot of people that worked very hard to bring the technologies together that eventually became the ARPANET, and it was ARPA is the Advanced Research Projects Agency, if you're not familiar with it, and it was started by the DoD specifically to look at how they could do computational time sharing, that is, have computers that are not next to one another talk across great distances. So the goal was, we need to have computers that can talk to each other that are not in the same room. That was it. That was the goal. Some people like to say that, okay, if in the event of a nuclear war, we want to have distributed systems so not everything in the Pentagon gets blown up. That may have been an element, but I don't know that that was necessarily a specific requirement. I wasn't there, to be fair. So maybe it was. So ARPA, the Advanced Research Project Agency, started ARPANET, and of course they didn't have resources of their own, so they depended heavily on academia. So universities and computer scientists helped build the first ARPANET. And on October 29th, 1969 at 22:30, the first message was sent on the two-node ARPANET. There were two nodes, and the message was LO. And then it crashed. They were trying to type login, And they made it 2 characters into it before it died, and then they rebooted it, and they eventually had the login event. So in October 1969, you can say that's when ARPANET actually existed. I would like to use this forum right now to start an urban legend that the first message typed on the internet was actually LOL. So if we can start that rumor now at HouSecCon 2015, that would be fantastic. Oh, and that message, by the way, was sent at UCLA. That was one of the universities that was heavily involved in that. It took them about an hour to get the system back up online, and then fast forward to December of that same year in 1969, and ARPA actually had 4 nodes on it, including UCLA, Stanford, UC Santa Barbara, and University of Utah. So, have you ever seen a topology map that simple before? I mean, that was the internet. In 1969, that was it. The whole bloody thing, right there. On Al Gore's napkin. Al Gore joke. Is anybody there? I know. So, over time, other education facilities and institutions started joining in, and the network kept getting bigger and bigger. And now here we are in 2015, and if you looked at a map of the internet lately, yeah, there's a lot of stuff on the internet. You all know that. So as I mentioned earlier, though, you know, the story is that it's an American thing that was started. A lot of people were heavily involved, so as I was doing the research for this little story, I concluded that the internet was invented by humans in the 20th century. That's, you know, there a lot of people take credit for it. But the important point, as I mentioned earlier, that it was designed for very, very specific purposes, and it had very specific design requirements that did not account for unauthorized users, and it did not account for non-private networks. Because remember, you had to be either in the DoD or a member of one of these education facilities to even get access to it. So the concept that there could be unauthorized users, it's not that they forgot about security, it just was not a design requirement. There would never be unauthorized users because you've got to be in the military or a scientist to get access to it. And that remained true up through the 70s, but then a funny thing happened. E-commerce happened. So the first, depending on who you ask, the first commercial ISP, Internet Service Provider, was either UUNet or The World. They were both in operation in the late 80s and the early 90s. The World kind of gets the nod because they had actual full Internet access, that is, unfiltered access to the Internet, by 1992. And very quickly, if you were online, how many people are over 40 in here? Okay, so you're my people, yeah. You remember, I mean, so my first email address I got around 94, 95 maybe, and yeah, so there were ISPs around, and you could get a crappy little slip account, right, and dial into a terminal somewhere and run Pine. How am I doing on time? Oh, I have time for this story. So I was telling my son, who's 12, he's never known a world without the internet, right? I mean, he's never been in a house that didn't have multiple computers in it. I tell him, like, look, in my pocket, I've got more computing power than the space shuttle, you know. To be fair, the space shuttle's computers are purpose-built and, you know, so on and so forth. But I had to I sent an attachment to his teacher or something, and you drag the document over and you click send and boom, off it goes. And I thought back to, you know, when I was in college and had to send an attachment in Pine, what an arduous process. Has anybody not had the pleasure of doing that? I'm telling the story anyway. All right, good. Somebody admitted. Oh, man. So if you wanted to attach something, you had to upload the file first through FTP to whatever your service provider was. So you uploaded the file. You FTP'd it up. Now it's in your home directory on your Unix host that's on the internet. And then you go into your mail client. Oh, wait, no, you don't. First, you have to UU encode it because it's a binary file. You've got to convert it to 7-bit ASCII. So you've got to run UU encode and hope like hell that who you're sending it to is also using UU encode and not binhex, right? If they're using binhex, it's a different encoder. Then you have to take that huge ASCII file, attach it to the email, and then send the email. And that took minutes. It took a while. And then when you received it, you had to detach that huge block of ASCII, run UU encode to get it back to binary, or bin hex. You know, you hope you have to use the same encoder on both ends. And then you had to download that file from your host through FTP and get it to your local computer and hope that nothing went wrong during all those steps and you could actually read the bloody file. And so using the computer back then in the 90s, or using the internet rather, was a completely different experience than what it is today. Well, why? Again, because the design requirements didn't take into account UUNet or the world. And when the world started operating as a for-profit to non-ARPA approved users, they would just let regular people. I mean, this was a network that was designed for and by computer scientists. So now when your mom or your uncle or your grandma calls and you become tech support, this is why, because it was a bunch of geeks like us that designed this thing. Commercial applications, and when you talk about e-commerce, I actually didn't remember this until I was doing the research. ARPA maintained control of the entire internet for a very long time into the 90s. In fact, commercial applications, that is applications with which you could make money, were specifically prohibited until 1995. Coincidentally, the same year that eBay and Amazon came to be, as soon as that restriction was lifted, those guys were ready to start their business model, and, well, you know where we are today. And that was during my career. I mean, I had already failed as a musician, and I was already a computer geek in 1995, and I remember when that happened. So it wasn't that long ago. I mean, some of us, you know, have been working that entire time. So, oops, sorry. The security concept, then, that I'm trying to get across to all of us is that an initial design requirement of any infrastructure is not necessarily what it will become, what its final use case will be. So as security folks, you can have all the, you know, scoping you want, but you have to know that once users get a hold of this thing, no telling what it's going to end up being. So we've got to constantly be agile in thinking once we apply humans to the technology, that's when things start going horribly wrong, right? The system by itself is fine. You know, add users and, you know, all hell breaks loose. That's how it happens. And that's why ARPA was started. You know, ARPA wanted to see, could they build this infrastructure for computational time sharing, distributed across great distances. So just as Eisenhower's roads fueled America's love for automobiles and exploring cities, now all of a sudden internet can allow, you know, at the time regular people could suddenly communicate and send emails to the other side of the planet. We could share digital data. And again, I can't underscore this point enough that it's not that the researchers back then ignored these potential security problems. It just wasn't a problem that they had to deal with at the time. And so as a result, you know, we all know that we end up kind of bolting on security to systems as an afterthought. Until we get to the point, I'm not the first guy that said this or gal. I mean, everyone says this. You've got to build in security. You've got to bake in security in the process at the beginning. We're still not terribly good at it, and we still end up kind of reacting sometimes at the very end and trying to add security to something that already exists. And therefore, you continue to have these problems. So what can we predict, then, if we take the Eisenhower Interstate system? The initial requirement was essentially give me a hard, flat surface. That was it, and let me drive around on it. Nowadays, if you actually, and believe it or not, I did geek out and started looking at like futuristic building techniques. There's adaptive construction materials that can detect a change in the temperature. So if the road gets icy, the paint lines change, so the driver can immediately be aware that driving conditions are changing. We've got toll roads. Again, for the Houstonians, we drive on them all the time. There's different ways of funding these infrastructures. And with some of the laws and for intellectual property and digital copyright, you know, we know that there's, you know, protecting intellectual digital property is a very interesting problem. Roads have sophisticated lighting. There's tests that have lighting that can follow the cars, that are only on when cars are driving on them, and dynamic lanes where The lines can paint themselves in different configurations depending on traffic patterns. Self-driving cars, I can't wait to get my first self-driving car. I cannot stand, I love Houston, been here 20 years, and I can't stand driving in it. So all of this stuff, we're going to have these things. Do you think there's still going to be automobile accidents? Do you think there's still going to be traffic jams? Oh my goodness, yes. Why? Because all this great technology is wonderful, but you apply us, the humans, you apply humans to it, and we're going to mess it up. Or the science might be good, but the implementation will be bad. How many times have you heard about cryptography being broken? Well, it does happen that it's broken because the math was bad. But very often, crypto gets broken because of a poor implementation. The math behind it is fine, but you implement it in a dumb way, and somebody's going to figure it out and take advantage of it, right? So we have all this wonderful stuff, but traffic accidents still happen because people are fallible. And we do dumb things. It's all of us. So what does that tell us about the internet? So, oh, by the way, the word internet, the first verb that was used in the documentation from ARPA back in the 50s and 60s was internet working. And they took that verb and shortened it and made it a proper noun. So the proper noun, internet, and it is a proper noun, by the way, always with a capital I. Thank you, Kevin. It came from internet working. That's just an interesting tidbit I picked up. So it was an infrastructure that featured packet switching. Packet switching was new and exciting back then. In the future, we're going to have math-based encryption that'll have elements of quantum computing in it. There are quantum computers that live in the lab. I think in the future we'll have encryption that's not just based on the fact that factoring prime numbers is hard, but rather it'll be, quantum elements that you won't be able to observe without changing. Where broadband is going to become more broad. I mean, think about the roads. There's parts of 59 that have 12 lanes on them. You ever been on that? 12 lanes. And they'll be dead stop during rush hour. My son asked me one day, I was with him, he's like, Dad, who are all these people? And where are they going? You know what? I don't know. I'm just trying to get home. So broadband's going to get more broad and ubiquitous. We're going to have virtually unlimited broadband internet access everywhere we are. We almost have that now. Physical possession is going to continue to lose value. I thought of this when somebody asked me about my CD collection. And I said, well, I don't have one anymore. I have lots of music that I purchased to listen to, but it all exists in the cloud somewhere, iTunes or some other cloud-based library. The physical possession isn't the thing that's important to me anymore. It's access to the information. I don't care about the CD. I get mad when someone hands me physical media. They're like, hey, here's this thing. I'm like, what am I going to do with this? I got to carry this around now? It's access to the information that's important to us. That's the 21st century currency, and that's the thing that we're concerned about. And so our InfoSec challenges, I remember when I had conversations about security 15 years ago, it was all network-based attacks. It was all layer 3 stuff. Now, today, we spend more time talking about application things, layer 7 attacks. It's going to move to layer 8. Those of you that know me hear me say layer 8 all the time, because I'm absolutely convinced that the most interesting part of the problem is where the technology ends and the user begins. The chair keyboard interface. Right? You know that one? That's the most faulty component. So I think that the prediction is, so even though I have all these lofty things that I've said here about, quantum encryption, the implementation will still be the challenge for us. We're still going to struggle with trying to predict how our human users are going to interact with it. And we all think, we're security experts. We're at a security conference. But, we make mistakes too. So the bad guys are really, really good at anticipating how the human is going to respond in unexpected ways to their advantage. So as security pros, I postulate that we need to do...
Hello, I'm Geek here. No one seemed to notice that the media froze up, so from here on out, it's silence, but then again, the video isn't that much longer anyway. Sorry for the inconvenience.